Hello, today we're gonna continue in explaining the properties of the logarithm. We're gonna talk about three properties. They're very important and we're gonna use them in the logarithm functions. The first one is if I have log b to x plus log by. So we add two logs together, okay, they have the same base, okay, and their coefficient is 1. They must have these two conditions. Same base, same coefficient, and the coefficient must be 1. This is equal to 1 log, okay, and the same base, and I'm sorry, this is y, and I take the product of both arguments, so that would be x, y. Let's get the subtract similar to that. Log base b x minus log base b y equal the same thing, and guess what? When we subtract, when we add, we make a product. When we subtract, we make a division of the argument. So that would be the positive one on the numerator, and the negative one must be in the denominator. Okay? The third property is log b x to p. So now I have the power p. What I have here, I'm gonna move the power as a coefficient of the log. So that would be p log x. So I remove the power of x, and it's gonna be a coefficient of the log x, right? Next to in the front of the log x. Okay? Let's work on that and to prove why is that correct. Let's set p to 2. So I have log b of x squared. I want to show that this is equal to log bx. Let's try that. First of all, I'm gonna break x squared down to x times x. So log base b x times x. Same thing. Okay? But based on this rule, I can rewrite x times x as log bx plus log b x as well, because these are the product of 2x. So this is xy. So that would be log bx plus log b of the other x here. Is it clear? Okay, let's combine the like term. Suppose that this is x and this is x. So log bx and log bx, 2 strawberries. So I have 2 log bx. So you see that I moved the 2 next as a coefficient of log bx. So this way is proving this argument or this property. Let's get some examples of that. So these 4 examples, I'm going to combine the add, subtract to make it 1 log. So I am combining 2 or more logs in 1 log. So let's get a simple example first. Log 5, base 5, 2 plus log base 5, 7. So I'm going to use the first property here. So the same coefficient, the coefficient is 1, same base is 5. So now I can use the first property. So log, same base, and 2 times 7. And basically 2 times 7 is 14. Okay? Let's get another example. Log 340 minus log 3, 5. Okay, here's the idea. Same idea, but instead of plus, I have minus. Okay, so instead of product, what would be a division? So that would be, let's test first. Is it the same base? Yes. Is it the same coefficient and the coefficient must be 1? Yes. So now I can combine them in one log. Log, same base, and then divide. So the positive log comes to on the numerator, and the negative one goes to the denominator. So 40 divided by 5 is 8. So I got log 3, 8. I hope this is clear. Let's get a third example. I have 3 log b to p. Let's make this b clear. I have plus 6 log b to q minus 7 log b to r. Okay, let's work in this example step by step here. Let me be here. We want to combine these together. Same base? Yes. Same coefficient? No. Is the coefficient 1? No. So I can't combine these 3 together unless the coefficient is 1. Now, here's a question. Is there any way to make this coefficient 1? 1, 2, 3. Yes, I can use this property number 3, but backward. I want to make this p over x here. So you see how it goes here? So I made the coefficient 1 by removing the p as a power of x. So now I'm going to use the same thing. Okay, the 3 goes as a power of p, 6 goes as a power of q, 7 goes as a power of r. So let's rewrite this down. So now I have log b p cubed plus log b to q to the 6th power minus log b to r to the 7th power. I am not done yet, but this one right now, I have the coefficient 1 in all of them, same base, so I can combine them in one log. So this is equal log b, base b, because everything is b. Now, whatever the positive logs goes to the numerator, and the negative log goes to the denominator. Now let's make fraction here. Log p cubed, positive, so p cubed goes to the numerator. Log b q to the 6, positive, so q to the 6th power goes to the numerator. Negative log b r to the 7th, negative, so it goes to the denominator. So I have here r to 7th. Okay? I hope that this is clear. Let's get one more example of this property. So I'm going to erase that here. Natural log of g minus 5 natural log of h minus 3 natural log of m. Again, natural log has or follows the same rules as log. But watch, the base here, if you remember from the last time, the base here is e. So here's e, 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 the same base. However, is the coefficient 1? No. So now I have to remove the 12, it goes to the top or the power of g. the 5 goes to the power of h, and the 3 goes to the power of m. Let's do that. So here is the natural log of g to which power? 12 minus the natural log of h to 5th power minus the natural log of m to the 3rd power. Now, same base, same coefficient, and the coefficient is 1. And now we can combine them together. Okay, so I have the natural log. The positive goes to the top, and the negative goes to down, or in the denominator. So natural log g to 12 is a positive. So g to 12 goes to the top. Okay, negative ln of h is fifth. So that is negative h to the 5th. And then m cubed, negative, so m cubed goes down. Okay? Alright, so in all of these problems, we were combining some logs in one log. Okay, let's do the opposite. I'm giving you one log, and you extend it to more than one log. Okay, let's get some examples for that. So first example is log 7 base 7 of 4 CD. Okay, so this is a product, so I'm gonna extend it to 3 logs. Log, I have product of 3 terms here, so I have 7, 4 plus, because it's a product, log 7 base C plus log 7 base of D. Is that clear? So this is a very simple example, but we're going to learn about the idea in the next examples. Okay? So the second example I have log base 3 of 9 p squared over q to the 5th. Watch something here. This is the whole of it is the argument. So I'm trying to break the argument down for each term would be a different log. So each term on the numerator must be a positive log, and each term in the denominator must be a negative log. So each log has a base 3. We start with the numerator first. So I have 9 plus log base 3 of p squared minus, because this is the denominator, log base 3 of q to the 5th. Am I done? No. What is log base 3 to the 9? In other words, 3 to which power equals 9? Yes, it is 2. So I get 2 here. Plus, I don't like this one. I have to move the 2 as a coefficient of log 3. So that would be 2 log base 3 of p. Similarly here, what should I do? Yes, negative 5 log base 3 of q. And now I'm done with this problem. One more example. Log x plus y to the 4th divided by 7. And I believe just this. Okay. So, what is the power here? What is the base here? There is no base. So by default, the base here is 10. You remember when we were talking about that the last time. Okay, so now I'm going to take the numerator as a positive log. So log, okay, and no base, which means that the base is 10, x plus y to the fourth, and then this is the denominator, so this is minus log 7. Now, as I did here, I'm going to do the same. So I'm going to move this 4 here. So I have 4 log x plus y minus log 7. And this my argument here is x plus y. Don't break it. This is one argument. Okay? And this is the end of the answer. This is the answer. Okay, one more example in this part. I have the natural log of the cubed root of xy squared divided by t cubed. Okay, so let's think about that here. All of these is the argument. Okay, so I need to break the argument down, and each one would have a separate natural log. Okay, first of all, I don't like write the cubed root in this form of radical form, but I want to write it in a power form, and in other words, I have to have a rational power or exponent. So will equal the natural log of, instead of having a cubed root, I can rewrite it as xy squared to which power? Rational? Yes, 1/3. Okay? And then I have here the same t cubed. So I didn't change anything. All I just changed is writing, instead of instead of irrational or radical here, I wrote it as a term with a power. Okay, now I will break it down. So I'm going to break the numerator in one term and the denominator in one term. So that would be equal to the natural log, the positive one, okay, x y squared all to 1/3, and this is the denominator, so it must be minus the natural log of t cubed. Okay? Now, I have to get rid of the coefficient. So I move the coefficient right in the front of the log, or the natural log here. So that would be 1/3 the natural log of x y squared minus, same thing here, I'm going to move the 3 here, I have the 3 natural log of t. Good, so now this is done. There is no change I have to do that, but I have a lot of stuff here. First, I can break x y squared down, or x and y squared. The second thing, I have to remove the power of y. So let's do that. So I have to take the 1/3 as a coefficient, because the 1/3 goes to everything here. You see where the 1/3 goes to all this argument. Okay, and then I am going to break this to natural log to x plus the natural log of y squared. Okay, and now minus, same thing, 3 natural log of t. Now, I still have a problem here. It has a power, so I need to write that down next to a natural log. So that would be 1/3 the natural log of x plus 2 the natural log of y minus 3 natural log of t. Make sure that this 1/3 goes to only this 2, because if you go back, that's the cubed root goes to xy squared, so it doesn't go with t. Okay, so now I distribute the 1/3. So I have 1/3 ln of x plus 1/3 times 2 is 2/3 ln of y minus 3 ln of t. And this is the solution of this problem. Alright, I think that is clear. If you have any question, please ask. Now, I'm going to go to something, a different idea. In here, I'm giving you x and y, and all variables. But let's deal with numbers and evaluate their log. So if I ask you, what is log 6, 3 plus log 6, 2? And how can I solve that? Okay, same base, same coefficient, the coefficient is 1, then we can combine them in 1 log with base 6. And because this is positive, so the argument would be the product of 3 and 2, 3 times 2, which is log 6 to 6. And what is log 6 to 6? So 6 to which power is 6? Yes, it is 1. You remember rule number 2? 6 b to b log b to b is 1. Okay, one more example. I have log 5 of 370, I think this is 3, oh, actually 5, minus log 5 of 3. Alright, the same thing, same base, coefficient is 1, then combine them together, but I have negative here, so the positive one would be on the numerator and the negative one would be in the denominator. I have 1 log base 5, this is positive, 375, this is negative, over 3, so 375, I'm going to clean this, 375 divided by 3, if you compute it, that would be 125. Now we compute that 5 to which power is 125. If you think that, that must be 5 cubed is 125, so the answer is 3. Okay? Let's get another kind of problems before going to the change rule. So now, I'm going to give you something different here. I'm giving you that log b to 2 is 0.6. I don't know what b is, but I know that the value of log b to 2, base 2 to 2, is 0.6. And log b to 7 is 1.3. Okay? So here's the idea. I'm giving you log b to 14. How can I compute this log in terms of these two logs I am given? So think about 14. Basically 14 is a product of 2 and 7. So I can rewrite this as log b 2 times 7. But again, this is a product, so I can extend it to 2, the sum of 2 logs. So I have log b to 2, this is a product, so plus log 2 to 7. Alright, so log 2 to b plus log 2 to 7, log b2 is given 0.06. So I have 0.6 plus log b to 7 is 1.3. And basically that gives me the answer is 1.9. Is it clear? One more example. I have log b of 3.5. I don't know what 3.5 here, but I know that 3.5 in a fraction is 7 over 2. I'm going to write it down as log b to 7 over 2. And now again, this is a division, so should that be extended as a sum or subtraction? Yes, it is subtraction, so the numerator would be the positive one, log b to 7, minus log b to 2. And now I know that 7, log b to 7 is 1.3 minus 0.6, which is 0.7. Alright, let's get two more examples. I have log b to 56. I don't know what 56 is, but I want to break this down. So 56 is log b 7 times 8. But 7 is okay, but I don't know what 8 is. But I know that 8 is 2 times 2 times 2. So I can rewrite it as log b 7 times 2 cubed. Right? Okay, now I break it down to two logs. I have log b 7 plus, this is a product, log 2 cubed. Wait, I have this is fine, but I don't have log base b 2 cubed. I have log base b 2, but not 2 cubed. So I'm going to use the power rule here to move the 3 to the front of the log. So I have here log b to 7 plus 3 log b 2. And what that give me? Log b to 7 given here is 1.3 plus 3 times 0.6. So that would be 1.3 plus 1.8, which is equal 3.1. Okay?